Welcome to the session for data visualization in R. In this session, we have to come across three major objectives. One is reading and subsetting data. Now, data that is available to us can be in any format. It can be either a Excel sheet, it can be a raw data that is in the form of text, it can be a tab delimited data, it can also be a comma separated values. Now it is possible to read those data inside the R environment. So that is what we have to see, how we can bring the data and external data into the environment and analyze it here. Then apart from that, we also have to see how to subset the data, that is how to filter the data and keep the data that is required to us. Also subsetting includes sorting the data. So we'll see it in this session. Along with that, we have to see certain special data types. So what are the special types of data that is available to us, or how to convert the type of the data, make the changes in the types of the data. Apart from that, we have to see a main part that is crucial over here is visualizing the data. It covers what our graphic system is, what is the system or a graphic system inside the R, that we will see. We will see how to plot in R. Then we have to see selecting the plot. So how will we select the plot and choose the plot that suits the requirement? So for example, there is a bar graph that can be generated, there is the pie chart that can be generated, there is histogram that can be generated, there is a bar plot that can be generated, a dot plot that can be generated, then there is kernel plot that is also possible to generate inside the R Studio. So we'll see all these things. Plots also need to be fine-tuned to match the requirements. So fine-tuning of the plots is also an aspect that is to be covered. Then we have to see visualization and creating the special data. So that means the data that is of maps. We have to see how to generate spatial data and also how to analyze spatial data, that is marks those special regions where we are analyzing the geographic regions in the data, that we have to see. Then there is a concept of heat maps that we have to see, which are very important nowadays. So these are the things which are to be covered inside this session. Hope to see you inside the session. Okay, in this session, we have to begin with reading data. Now, before we proceed with reading data, we have to understand the concept of directory and how to change the directories and what are directories at the very basic level. So directories in a layman language are the folders where we either store a data before processing, so where we keep a raw data, for example our Excel file, so which maybe we are using for loading a data in our environment, or maybe is a folder where we'll be keeping the output files. So directory in short is a folder where we keep files, we use them as source or as a destination of all the results that we create after processing those files. So in our studio, we have a very brilliant feature where we can directly link onto the directories without writing the commands. So for setting the directory, we can go on to the session, and in that we have an option set working directory. We can go and choose directory. Now for me, my file is in this particular location. So in Amit projects in our project data. So you can choose the required directory where you'll be keeping your own files and then select that particular folder. So if you look at console now, it shows set WD and the location that I have chosen is being reflected with this particular command. So now my files which I'm going to use for this video are stored in this particular location. There are certain CSV files, for example they are comma separated value files, they can be Excel files. So one on one will be using them. So now we'll start reading those files. So reading those files means loading the data in those files in an object. Now we already saw how are we creating the object in our environment. So let's start building those objects and reading these files. And now it also depends where have you kept the file. Now for example, file can be anywhere. It's not necessary that the file has to be in the directory that you are currently working with. It can be at any particular location. It can be in the same directory. It can be in another folder. It can be in another directory. So we'll see two ways for loading those files in particular object. So now let's start with giving out the object name. So as we saw, we give a name to the vector, or we declare the vector. In a similar manner, we'll declare the object. Object is a vector, but this time it is consisting of the huge data. So for example, let's name a vector as data CSV, and now let's just start reading the CSV file. So to read a CSV file, we have got a very simple command over here which says read.csv, and inside the bracket in quotations we'll specify the name of the file if the file is present in the same directory which we are working with or which we have set in a session taskbar. So for example, I have a file with the name menu, and we do not have to forget specifying the extension of the file. So now the file menu.csv is loaded inside the objective data.csv. Now if I have an intention to view whether the data is correct or not, or whether the data is even loaded inside the object that is being created, so I have to type the name of the object data CSV, and I am now able to see that the data that was in menu.csv is present inside the object that I just created. This is one way of creating the object and reading the file inside the object. There is another way also. So now, for example, let's create the same object. Say for example, let's name it differently, data CS. And now my file is in some other location which is apart from the directory I have set. So now what will I do? I'll keep the command same because the format of the file is not going to change. And in the quotations, now what I have to do is I have to specify the particular location inside the computer or the drive where I have saved the file. For example, this is the location where I have kept my file. So, but there is one change that is required. We need the backslash everywhere. So we'll change it every place. And now the name of the file also needs to be specified because that's really important. So menu.csv, and now hit the enter. So just confirm whether it is loaded or not. So data cs, and now hit enter. Now again you are able to see the file that I was reading, it's read and is stored under the location and with the object data cs. So this is how we can read CSV files in our studio. So you can go ahead, practice loading certain files in our studio. In the next video we will see how to load files from Excel sheets or Excel files into the object in our studio. Till then, keep practicing. As we saw earlier, we created objects. For example, we created data CSV. This object is known as data frames. Data frames are like matrices, but here they have rows and columns, and rows and columns can contain any type of a data. So this is got a combination of rows and columns like Excel sheet. Now there is a way to explore the part of object or called data frame we can see. So for example, if we want to see upper part of data frame, that is initial readings or initial rows and columns that are present, we can use a command called head, HEAD, and in the bracket we can specify the name for the object or data frame that I wish to see, and you can see over here the initial certain objects or certain rows are present when I have written head data CSV. Similarly, we have tail, and in the bracket we specify data CSV. So this gives us the last certain objects or certain rows that are present in the data set. So it says from 255 to 260 are on the display. So 255 to 260 numbered row are on the display in here. So data seems be shuffled because there is a less space to occupy in the console, but we can see a number of series over here. So from the 255 onwards to 260 are on the display. So this was about exploring the data set with respect to verifying what part of data is correct or not, or whether the data is actually loaded is right or not. So we need not see all the observations, we can just see the upper part of the data and lower part of the data just for the verification purpose to understand whether what we have loaded under the data frame or object is correct or not. Now next part is to understand how to read the Excel file in a data studio. So let's do it. The most common question that we usually come across is how can we read an Excel sheet inside the RStudio? So answer is no, do not read any Excel sheet inside Studio because it is way too complicated. In order to read Excel sheet, you store the Excel sheet in a CSV format. So for example, we'll see now. So for example, if I have this file with the extension in the name is.xlsx, this is pretty difficult to open in the R. So the suggested way is you save the file with the name. So whatever name you want to give. So for example, it is another American B01362. This is actually a series. So we save it as 36. Fine, that is, and over here we can change it to the CSV. So comma delimited. So it will be saved as a CSV file, and then you hit the save and go on to the folder. So now we have the file with the extension CSV, which is easy to open up. So raw data always with the comma separated values is easy to open up in R in compared to XLSX sheet. So we prefer to deal with CSV files rather than XLSX and XLS files in RStudio for convenience and for ease of use. Another type of a format that can be opened up is tab delimited file or a space delimited file. So let us look at how a tab delimited file looks first of all. So as you can see over here, these are tab delimited files. So these are text files. Extension they have is .txt, and if you observe over here, there is no comma for a major separator. So a separator between date time and pickup is a space. So these are the tab delimited files. We can read these sort of files in RStudio. So let's look at the command first. So the command is really very simple. Under the object name txt, we have to say read dot table, and in the bracket we specify the name of the file. So let's do that. So in the command, under the quotations, we have to specify the location of the file and name of the file, and along with that we have to specify whether we need header. So header is required if in case, so you can type on true, we have got some error over here. Now problem here is there was still a comma that was left before the last column. So R assumed that there are more columns than specified. So what we'll try to do is we'll try to read some smaller file, a smaller version of that file which has less observations and comma being removed wherever it was unnecessary to include those commas. So let's do it, and the address still remains same. So now problem was every delimited space is being considered as a different column. So now I've changed the structure. So now it doesn't give any error, and if you look at txt now, if you try to look it, I have just modified the address column over here. There were too many data over there, so I just removed it and just only kept the numbers over here. So the space is usually considered as a different column altogether. Tab, because this is the tab delimited, this means a data is delimited by a gap. So every gap was being considered as a different column, so I had to remove it. So we have to be very careful while we are dealing with such type of a data. So in this case I removed the, just to show for an example, I removed the other columns or other data after space that was providing the entire address, and I could only keep the numbers over here. This is just for the reference, just for the understanding. Okay, now for example over here we are dealing with a different type of a data. So for example, if you observe here, this is a different type of a data. For example, if you observe here, each column is separated by a comma. So now in read.table, we need to specify the separator so that it understands what have we used to separate the data or separate the column in this data. So for example, what we are supposed to do is we are creating a same data frame, so txt, and now the file address is same. Header we specify as we need header in the result, and now we specify one more parameter, that is separator, which is indicated as scp. And once you hit the enter, automatically R understands that the separator is used as a comma. So wherever there is comma, the column changes. So similar thing has been done over here, but comma is not the default delimiter for RStudio. That is why it uses space as the default delimiter, and while displaying the data, it doesn't consider any comma in here. So for example, date, pickup, time pickup, and address, and then if you see the values under those columns are separated by space, so R have considered them as separate data because they were separated by comma, which we specified using a scp parameter in read.table. So this is about reading other types of files apart from CSV in RStudio. So go ahead, do some practice, get some files in your system, do connect it to the RStudio, try to read the files, do some experiment. In the next video, we will see how to work with these data frames that we saw, that we just created. So till then, keep practicing. In this video, we have to see how we can extract the data from a vector and a data frame. So extracting over here means, if suppose in a vector there are 5 elements and I only intend to approach or use the third element in that vector, I can directly extract the third element without affecting or without extracting other elements. Similarly, it is possible to do the same thing with data frames. But for the time being, let's begin with the vectors. So for example, num1 is the vector that I am creating, and I have to give out certain values to it. So for example, 1, 2, 3, 4, 5 and 6. And we'll create a second vector named 2, and we'll give out some values to it. So for example, 25, 26, 30, 32, 22 for example, and then hit the enter. And now for example, in number 1 or in num1, from that vector I intend to extract a third element which is 3. So how will I do that? So to do that, I have to write num1 and I require a square bracket, and in square bracket I write the number of the element. So I have to, for example, extract third, so I'll write 3, and as soon as I hit enter, you see the 3 is being extracted. If you try out with num2, so you write 3, 30 is extracted. This is the way each element in a vector can be extracted or accessed using the indexing. So indexing is the position of the number or position of the element in a vector. So we directly write the index number or the position and extract the value from the vector. The same thing can also be done with the data frames. So let's just do that. Now let us look at the multiple ways of giving out the indexes to extract the values. Now we had two vectors, so let's do some tricks with num2. Now I can provide a range of indexes. For example, I want three numbers, so initial three numbers or maybe initial four numbers. So I can say 1 to 4. So 25, 26, 30 and 32 were the elements that were in the range from 1 to 4. So those are being extracted. Now let's create another vector. Say for example, select num. This is the name of the vector, and it has some values. Say for example 1, 3, 5 for example. And now I can use this vector to extract the values. So for example, select num, I put in a square bracket, and now if you are able to see, it's 25, 30 and 22 have been extracted. So values at the position 1, 3 and 5. Same thing you can do with num1, 2. So in the bracket we can say select num. So 1, 3, 5 is being extracted and is available at the output. Now suppose you wish to remove the first element. In the bracket you can write -1. So if you are able to see, the first element is removed and rest of the elements are available to us. So these are the ways in which we can extract the element from the vector. In the next video we have to see how we can extract values based on the range of the values or based on the values that a vector has got. Till then, keep practicing with more numbers and see you in the next video. And now let's just select the values based on the values that a particular vector contains. So that means let's select a subset. So now first let's look what num2 consists of. So it consists of values 25, 26, 30, 32 and 22. Now for example, if I wish to select those values which are higher than, say for example 27, so let's do that. So what we'll do is, so in num2 we will say in square brackets we said num2 greater than, so what value it should be, for example 27. So obviously there are two values, those who belong to this range. We could have write anything. So for example we can change it to 30, so it's only 32. We can change it to 29. So again two values, 30 and 30. So this is the subset that we are choosing. Now there can be multiple conditions depending on the requirement. So for example here we can also say, so num2 greater than 25, and that means we can give the ampersand and say num2 less than 30. So any value that belongs to the range which is greater than 25 and is less than 30 will be reflected. So for our example it is 26. Like, and we can lay an OR condition too. So for example we can say num2 should be greater than 20 or num2 should be less than 30. So those values, those who belong to this category, actually for this example, all of them belong to this category. So you can change it to, say what, 28. Okay. Or you can say should be greater than 20, so that condition is satisfied. So definitely OR will select all those values that are present inside the vector num2. You can also say in num2, say for example, num2 is equal to 22. So if that value is present, that will be reflected. Or you can say if it is equal to 63, so it returns numeric 0 because this is not the value that is currently present. Or you can say is not equal to 63. So, or else we can say (25). So those values which are not equal to 25 are to be thrown out. So 26 or drawn out. So 26, 30, 32 and 22 are not equal to 25. So these are the values that are being extracted. We can also change the values which are present inside the vectors. So let's see how to do that. So first of all, let's observe what is in num1. So there are 6 values from 1 to 6. For our example, let's say if we want all values which are less than 4 to transform to 0, we can do that. So you can say num1 and in the bracket num1 less than 4, and what value you want for all the values which are less than 4, we want them to go 0. So now if you check num1, you find all the values that are less than 4 have been replaced by 0. This is about subsetting and extracting data from the vectors. Now I want to go ahead, do some practice, get some hands-on with changing the values and getting the values out of the vectors. In the next part, we are going to see how to subset the data frames. So wish to see you in the next video. Now let's focus on to the next aspect, that is subsetting a data frame. So subsetting data frame can be done in two ways. One is applying the square brackets that we saw earlier in the case of vectors. Another is using a subset function. So we'll explore both the ways. So let's begin by creating a data frame first. So let's say data frame, and in this data frame, let's read the file read.csv and specify a file. So data frame is the created data frame of the menu.csv which we used earlier too. So now let's see how we can subset the data frame. So the basic command is, for any data frame, we have to say or specify the row number and column numbers. This is a very basic method of doing it. Now let's just move ahead and try some examples and other various ways too. Let's just first know how many columns and rows data frame has. So it has got 260 rows, and how many column it has, let's try to know that. And it has got 24 columns. So, and now we'll input the data. So name of the data frame, which is in our case is the data frame, and in a square bracket just specify, so 5, 6. So fifth row and sixth column, we got the number. So there is a number 23 in fifth row and sixth column. So this is how we could able to extract it. You run names command just to know names of the columns here. So you can say data frame These are the names, and while indexing them or while extracting data, we can also make a use of these names. So for example, we can say data frame, and in the square bracket you can specify 5 comma category, and so it says a value is breakfast at 5th number row and column category. We can extract multiple rows if we wish to. So for example, in square bracket we can say 1 is to 4. So these are the 4 rows that I intend to extract from category. So see, for example, all of them are breakfast, and levels are beef and pork, beverages, breakfast, chicken and fish, coffee. So we could able to extract 4 rows from one particular column. We can extract all rows of all columns, or we can extract specified number of rows of all the columns. And to do that, what we can do is we can say data frame, and in the bracket say for example 1 is to 5. These are the number of rows that I wish to extract, and if I don't specify the column name or column number, so it is understood that all of them are important. So if you look at it here, so 5 rows have been extracted from all the columns when I have not specified which column I want to. What if you want all the data from a 5th column? Say for example, so put a comma because the space for row needs to be empty, and I only want 4th column. So this is how a 4th entire column is being extracted and is available to us. Now suppose for example, I have to lay a criteria for selecting in a one particular column. So I can say data frame and dollar symbol as we used earlier too, and I am choosing serving size. So now in the bracket we have to say data frame. Again the parameter will be same, serving size, but now we lay a criteria that it has to be greater than 10, say for example, and hit the enter. So we are able to see selected those values which match the criteria. Or for similar example, we can say, or for a similar, we can go down and check for, say for example, we lay a criteria on the cholesterol. So we can again say data frame and dollar. So category is what? Cholesterol it is, right? Is greater than 350. So now we got the values which match the criteria. So this is about subsetting using square brackets. In next video we will see how to do subsetting with the subset function. Till then, keep practicing with multiple values and in different ways, and providing different values or maybe creating different data frames. Hope to see you in the next video. Okay, now next part is we have to now subset data, but this time we'll be using a subset function. So let's make a use of that function. So function is quite simple. In subset and in the bracket, you will specify the name of the data frame and the names of columns. So for your reference, again I'll say names, and I will try write menu here. So these are the names basically. So let's now write again that subset. So this was for your understanding. Okay, and in subset we have menu, and if I look at the data set over here, so these are certain names listed under the items. So I can choose any name. So for example, I take it a Big Mac. So this is the data from the MACD. So I'm just, and what are the calories? So what is the amount of sodium that is there, and sort of things in here in this data set. So I take the name Big Mac, and under the item, because this has to be subset. So subset means searching the required thing. For example, I'm looking for a Big Mac. So under what observation or how many observations or how many rows has this certain value. So this is about the subset. So it says only 43 number has got these value, and these are the details of the particular row you have asked for. So this is one example. Let's look at another example. So now we say we might take any other name now. Let's remove this Big Mac over multiple rows with the same value. So for example, we say egg McMuffin over here and just place it. And this is because this is broken. Okay. So let's then hit the enter. So it says first row is having these values, and these are the rest of the observations that belong to the item you have queried for. We can lay more than one criteria. So we can say egg muffin, and it can be with some other combination. Say we can say the amount of sodium, for example, might be, you may observe the sodium level. So for in this case, we will just go and see what sodium is at, because we want this particular observation to be populated. So 750 here. So it says first category match that you have asked for. So this is the way we can give out the more than one way of querying the things. So this is about how you can subset the data, and you can go ahead, keep practicing, make some data sets, try to create some data frames, and try to extract data out of it and subset the data. In the next session, we have to see what are the special data types, and then we'll move ahead with the data visualization. Till then, keep practicing.